All right, guys, 10-7, wrapping up chapter 10 with something very, very important to your mathematical futures. It is circles in the coordinate plane. The equations of a circle. Man, what? Equation for a circle? Crazy. Yes, we indeed have equations of circles. Important for a couple reasons. First off, pre-calc, definitely have equations of circles. And actually, your pre-calc teacher will get into ellipses and all kind of parabolic functions and equations and things like that. Also, on the SAT, they actually incorporate equations of circles now. So this is a good video to keep with you. I also have it on my YouTube channel for in years in the future if you forget or if you just want to refresh on things. But it's something that you'll probably take the SAT during your pre-calc year in high school, and you might not get to equations of circles when the time you take the SAT. So this is an important one to kind of keep in the old memory banks here, my friends. And speaking of friends, we are gonna take a little trip back to something I know you guys love from the class days. Look at that. It's Geogebra. All right, I'm gonna use Geogebra here to help illustrate what's happening before I get into the lesson with equations of circles. So let's see here, my friends. I know you're familiar with equations of lines. All right, so if I sketch a line right here, and then the beauty of Geogebra, it shows us, let's go into Slope-Intercept Form. You guys are really good with this kind of stuff, right? You got y equals mx plus b. You know that your intercept is 1. That's the plus 1. The slope up 3 over 1. Slope is 3. So equations of lines. Well, guess what? Circles have equations too. And so, let me get a new one going here. And let me show you what equations of circles looks like. And we were going to actually use Geogebra in our class if we were in the building. So that's why I'm using it here today to try to develop what's happening with the circles. I want you guys to try to, just based on my circles I draw here, generate the formula. So let me start out with a circle centered at the origin, and let's go out to a radius of 3. All right? So now look what happens over here. The equation of the circle is x squared plus y squared equals 9. What? Yeah, well, it's weird. It's not linear anymore. It's not a line anymore. It has x squared in it and y squared in it. So that'll be your clue on SATs or in pre-calc that you're dealing with a circle when you see an equation that has both x and y squared. All right, so let's see how this is going to change. And you'll probably be able to develop the formula as I alter this circle. So now let me take point B and let me expand. Let me not do that. Let's undo that bad boy. So let's go to my little move feature and let me expand my radius. So let me go out to 4. What happened? The only thing that changed was this right-hand side of the equation. It went from 9 when it was here at 3 to 16. So what do you think is happening as the radius goes from 3 to 4? The right-hand side of the equation for a circle went from 9 to 16. So you can probably guess. Let me take it out one spot further. So now my radius is 5 and my right-hand side is 25. So you can probably see what's happening. Your right-hand side, your radius, is just going to get squared as you go bigger and bigger. As you can see, I was at 9. There's 16, 25. So obviously, guys, the right-hand side of this equation is just going to be, okay, there. It's just going to be r squared. So if the radius is 3, you'll have a 9 over here. And when we get into the notes, I'm going to show you why this is happening. I just want you to see where it's coming from now. All right, so now check this out. Let me go with a new circle that's not centered at the origin. Let me center it, no, I don't know, right here. And let's just make my radius 2. So now look what my circular equation looks like. It's like, now I don't have x squared, y squared by itself. I've got a plus 3 next to this x and a minus 4 next to the y. Well, what would the coordinate be? What's the center of this circle? It's negative 3, positive 4. So my center is negative 3, comma, positive 4. And now look, that's some mouse pen skills right there. All right, so now look how that affects the equation of the circle. When I didn't have anything, when I had 0, 0, I just had straight up x squared plus y squared. But then when I moved the center up to some other point, in this case negative 3, positive 4, look what happened. Well, the sign switched. So it went from x to x plus 3, and then this is now y minus 4. So you can probably tell what's going to happen whenever we take a look at the actual equation. It's the opposite, isn't it? So you're like, if I have a negative 3, then I got to put it in as plus when I enter it into the equation. And then we already saw what happened to the radius. The radius for this new circle was 2, so the right-hand side is 2 squared, or 4. So guys, you have GeoGebra if you want to mess around with it. Essentially, that's all I'm doing here to show you what's happening as we alter the equations of circles. And if I took a look at this new one, if I changed its radius, it doesn't change the center. All it's changing is the right-hand side. So the radius is going to affect the right-hand side. The center will be affected on the left-hand side. So if I drop this down, now it's plus 3, and y is minus 3 because y is up at 3. If y goes to 2, you see what's happening with the center, the in parentheses there. If I take it all the way down to the x-axis, now I'm back to y being 0, so it just completely goes away into y squared. Oh, I love it. Love me some circle equations. All right, so now let's see how that's going to be affected in the notes today. So in our textbook, you've got writing and graphing equations of circles, and the Pythagorean theorem is going to help us. Oh, you know it's coming. So here we go. Standard equation of a circle is this is what you need to take with you. X minus h quantity squared plus y minus k quantity squared equals r squared. And h and k, that's your center. All right, so that's the new thing here. So it's centered at h and k. Now if we look at the picture, and x, y are going to be points along the circle. Just like when we have y equals mx plus b, you could alter the x and the y, the b, there was different things happening in there. There's different things happening in the equation of the circle, but don't freak out. It's just like what we just did in GeoGebra. We did with the equations you're looking at on the left-hand side under algebra. All right, so now let me show you where this comes from real quick. And if you look at the diagram here, you've got the center at HK, that's just some XY coordinate, and then you've got a point XY on the actual circle. All right, so now they could have done X2, Y2, and things like that, but they just picked new letters H and K. And that's the universal general equation for circle center, H and K, centered at H and K. All right, so now if I want to figure out where this whole thing is coming from, think about Pythagoras, all right, which AKA is the distance formula. So if I want to get R, which is the hypotenuse of this thing, so the distance formula tells us that we need to go x2 minus x1 quantity squared plus y2 minus y1 quantity squared, all right, square root of all that. So now if I substitute in to find what the radius is over here, then my radius is essentially looking at these coordinates right here. So now I have x minus h quantity squared plus y minus k quantity squared. That's using this point and this point, a point on the circle and the center of the circle. So now, if I want to get rid of the square root, I would square both sides. And so that leaves us with r squared equals x minus h quantity squared plus y minus k quantity squared, which is the formula for the equation of a circle. So there you go, guys. That's where it comes from. It's essentially using distance formula, Pythagorean theorem, to generalize what's happening within a circle. So now the problems. Example 1, write the standard equation of a circle. We've got 2 examples here. One is shown, and then one is just tell me what to plug in. So the circle at the left. So I'm looking at this circle here for part A. And you're like, all right, well, the center of this circle is the origin, is 0, 0. So my center is 0, 0. And, oops. And then the radius, it's always nice when there's a picture, you can just kind of tell. The radius is 3. So r is 3. So now if that's the case, just like those GeoGebra ones we looked at, when you don't have any coordinates other than the origin, it's really nice. All you can just do is like x squared, because there's no h. H and k are 0, 0. So x squared plus y squared equals r squared, which in this case is 9. Now part B, it's even easier. They come out and tell us, here's the center and here's the radius. So x now is a 0, so that's nice. I can just be like x squared. Now the y has something happening with it. So now what do we do when it's negative? Well, you're going to flip the sign because the general equation has a negative in it. And then over here we have to take 4.2 and square it. Right? Which and 4.2 squared is 17.64. So technically the actual one you'll see right here is 17.64. All right, so now try the monster progress real quick. Pause it at the bottom of the page here. All right, and back again. Hopefully you got x squared plus y squared equals 6.25. And number 2, you've got x plus 2 quantity squared plus y minus 5 quantity squared. That's the plus symbol. Equals 7 squared, which is 49. So first things first, writing the standard equation of a circle. All right, next, same thing. We're still writing an equation of a circle, but now we got to do a little bit of work. They give me the center at 1, 3, and then they give me a point on the circle. So that is a fancy way of getting me to find the radius. So you can do it a couple ways here. Of course, you could do the distance formula. You could also Pythagoras this bad boy. Drop down a little right triangle, and this might be easier for this one. You got 3 on this side, and you got 4 across the bottom. So I want you guys to get good at, hey, when do I use Pythagoras? When should I use distance? And so you know your Pythagorean triples. If you don't, you can just do 3 squared plus 4 squared is r squared, and you get your radius of 5. So now, once you have your radius, either using Pythagoras or distance, well, you got the center, and now you got the radius, so you can just plug it right in to the standard equation. So x, now I got to change the sign, so it's x plus 1 quantity squared plus y minus 3 quantity squared equals 5 squared, which you can just write as 25. All right, so the biggest thing kids really mess up, even on SATs, is just forgetting to square it. Don't forget that's r squared on the right-hand side of your equation. And that, my friends, is example 2. All right, example 3. The equation of a circle is x squared plus y squared equals 49. Find the center and radius, and then graph it. So this is going backwards. Now they're starting me out with the equation, so I should be able to tell what the center is and the radius. So I know there's nothing next to the x or the y, so the center, say it with me, has to be 0, 0. Remember, it's like Woodsy the owl right here. It's like, woo, woo. Okay. And then the radius, well, if I have 49 on the right-hand side, I got to take the square root of that, so my radius is 7. So now if you're going to graph the circle, you sketch it real quick. Centered at the origin, 1, 2, 3, 4, 5, 6, 7 is my radius. So it would look a little something like that. All right, pause it. Monitor progress. All right, we're back. And here we go. The equation of a circle is this. So again, I got to flip. If I got x minus 3, then that's going to give me a positive 3. Nothing next to the y, so that gives me a 0. And remember, this is in our squared form, so square root it to get what the radius is. Yeah. And the next one, we've got, let's see, the point 3, 4 is on a circle with a center 1, 4. Write the standard equation. So now you got to do a little bit of work. Again, like the one where we used Pythagoras, I used the distance formula on this one just to show you what's up. And so the distance between, so you got to take subtract your x's, 3 minus 1 quantity squared, 4 minus 4 quantity squared. So your radius is 2. So don't forget when you plug it in, it's got to be 2 squirt or 4. And the center was 1, 4. So you got to put minus signs in to the standard equation. So you're flipping it. All right, guys. Let's take a look at what we got here. The last concept today, writing a coordinate proof. So you're just actually going to show what's happening. Prove or disprove that the point lies on a circle centered at the origin containing a point. Okay, so think about what we're doing here. They give you some rando point, and you want to see if that point is on the circle centered at the origin. So you know your center is 0, 0, and containing the point 2, 0. So this is a fancy way of getting you to find the radius. Now, if it's easy like this, you might be able to tell. My center is 0, 0, and then there's a point 2, 0. So you know your radius is going to be 2. But let's just say that it was some weird thing, and we had to find the distance between them. So your radius is going to be, subtract your x's, square it, subtract your y's, square it. So that's gone. So 2 squared, of course, my radius, square root of 4 is just 2. So again, you might be able to logically tell on this one, but let me just show you where it's coming from in case you need to get weird with it. All right, so now we have the radius and we have the center. So I want you now to think about your equation of your circle. So the equation of your circle, since there's no numbers, it's just the origin, is going to be x squared plus y squared equals 2 squared, or 4. So now here's what you do. To check and see if this point that they give you, in this case root 2, lies on that circle, just plug it in. Your x value is the square root of 2. This is just like if you're checking if a point's on a line, you plug it in for your y and x and see if it equals. And then the y value is also the square root of 2, so plug it in. And now you're checking to see if that equals 4. If it does, then you know it lies on the circle. So the square root and the square cross out. 2 plus 2, yes, it equals 4. So yes, it lies on the circle. All right. Back that up, watch it again. If it didn't make sense, try the last problem, pause it, and we'll wrap it up. All right, so hopefully you got no on this monster progress question. Prove or disprove that the point 1, root 5 lies on the circle, centered at the origin, and containing the point 1, 0. So, centered at the origin. And then you've got contain the point 1, 0. Again, you might be able to just tell your radius is 1 real quick. If not, you can always use the distance formula. And once you get your radius of 1, again, what are you talking about here? Well, that's how far away the point that's on the circle is from the center. That's your radius. All right? So once you get your radius, now you're checking. It's at the origin, so it's x squared, y squared. Plug your radius in, and then you're checking to see if the point that they give you 1, in this case 1 root 5. So plug the 1 in for the x, the root 5 in for the y. Check it. No, it does not equal 1, so that point cannot be on a circle centered at the origin containing the point 0, 1. That's it. There's a lot of information today. You might have to watch this one a couple times. Again, keep this one with you as you move forward mathematically. And hopefully you miss GeoGebra as much as I do. And peace.